Chapter 3 will be quite a review from Algebra 1. It's very important that you read every section thoroughly, making sure that you pick up on things that you might have forgotten. While we'll cover a lot of things in these videos, we will not cover everything. In the first section, 3.1, we're going to talk about the rectangular coordinate system, which is basically your coordinate plane. Hopefully what you remember, we've talked about this several times in geometry as well, how to plot a point. When you plot a point, we have x and y. X goes left and right, y goes up and down, positive x to the right, negative to the left, positive y goes up, negative y goes down, and the quadrants are as followed: 1, 2, 3, and 4, and we have the origin right here. A lot of this section is just plotting your points and then graphing. So we're going to take a look at this first one where it says complete the table for 3x minus 4y equals 12, and then we're going to graph. So if you remember how to make a t-chart, I'm going to put x right here, y right there, and we're going to start doing this one by doing our x and y intercepts. Those are very nice and easy ways to get 2 points. To find the y-intercept, you're going to plug in 0 for x. To find the x-intercept, you plug in 0 for y. And what you're just going to do then is you're going to solve. So when I plug in x equals 0 right here, I'll get 3 times 0 minus 4y equals 12. And then I'm going to solve for y equals negative 3. When I plug in y equaling 0, I'll plug in 0 for y. That will cancel out, and x will equal 4. So we'll have 2 points, 0, negative 3. I would like you to do this on graph paper, but you'll get the idea just with x and y axes. So this is 0, negative 3. This will be 4, 0. And you need just 2 points to make a line, so you're just going to connect those to get our line. It's always a good idea to do a third line just to make sure that it's in sync and linear with the other two. You can do that by basically picking any number for x and y and then substituting into your equation. It's kind of nice though if you have a multiple, it will kind of be consistent. You won't have to do with fractions. So if we plug in 8 for x, this would be 3 times 8 minus 4y equals 12. That would then give us negative 4y equals negative 12, and therefore y equals 3. And if we were to continue this, 8, 3 would be about there. And if we continued, it would go through that. So that shows us that the lines are collinear and they form a straight line. When you're doing this on your homework, please use graph paper and a ruler or straight edge. A form that hopefully you remember from Algebra 1 is called standard form. It's when you have a linear equation that looks like this: ax plus by equals c, where a and b cannot equal 0, and usually a is going to be positive and your a and b will be integers. Well, a, b, and c will be integers. The following equations are technically in standard form. The first one that we're going to look at is y equals 2. The next one is x equals 5. And the last one is 2x plus 3y equals 0. Following the format that we did in the last example, let's make a t-chart for these. Now, I know a lot of you are going to know exactly what these are going to look like without doing this, and you guys can do that in your homework, but let's explain why. For the first one, y equals 2. If I want to make a t-chart and I'm picking, let's say, some random values for x to plug in, there's actually no x to plug in there. But what we do know is that no matter what x, my y value will always be 2. So I'm always plugging 2 in there. So when I go and I graph or plot each of these, 0, 2, 1, 2, 2, 2, and if I kept going, it would always be 2. My height would always be 2, y equals 2. Therefore, it will be a horizontal line going through the y-axis at positive 2. You can kind of get the same idea, I'm sure, with number 3, x equals 5. So if x equals 5, that's telling me every single value will be 5. No matter what number I put in for y, x has to be 5. So if I go to plot these, 5, 0, 5, negative 3, 5, 2, 5, 10, you'll see how they line up vertically. And if I connect those, you have a vertical line going through positive 5 on the x-axis. You do not need to do T-charts for these unless it specifically says so in the book. You can always know that y will be a horizontal line, while x equal to the number will always be a vertical line. And finally, let's look at number 4, where graphing a T-chart, and if I go to do my x and y intercepts, it's not as easy as it may seem. So if I put in 0 for x, 2 times 0, plus 3y equals 0, you'll notice that when I go to solve for y, it's at 0. And if I do the same thing for y, it would be at the same point. So the same point is at the origin, and we only have one of them, so therefore it can't graph us a line. So what we have to do is you can pick any number whatsoever, and all you want to do is just plug it in up here. So if I picked 3 to put in for x, 2 times 3 plus 3y equals 0, I would just solve for the missing variable. And again, it doesn't matter what number you use as long as it's non-zero. So we get 3, negative 2, that would be down there. And then you just need to connect that, and again, 2 points create a line. The next thing in this section is midpoint formula, and that's calculated by taking the averages of the 2 points and dividing them by 2. First taking the x's and then taking the y's. And again, the midpoint formula is if I just have 2 points and I need to find the middle of them on a line. We're not going to do any examples because we did plenty of those in geometry, as we did with slope of a line. And that starts section 3.2, slope of a line, which is rise over run. And you can calculate that by, in your numerator, y2 minus y1 over x2 minus x1. You can also do it visually if you need to. If I have a point here, I just count the height, and then I count left or right. And I could do that vice versa. I could go down and then left. It will give you the same thing. And finally, slope intercept should be something else that you should remember from Algebra 1, and that's y equals mx plus b. M, as you hopefully know, stands for your slope, and b is your y-intercept, and that's 0 comma b. Since it's y, you want 0 to be the x. Now if we come back to our vertical and horizontal lines, let's take a look at these graphically, what they look like. X equals negative 4 is a vertical line going through negative 4. y equals 3 is a horizontal line going through 3. And if I calculate the rise over the run, you'll notice that this always has a rise. I could go up 1, 2, or 3, doesn't matter, but it has no run. Therefore, the slope of a vertical line, or x equals a number, will be undefined. Whereas the slope for y equals 3, or a horizontal line, it has no rise, but it has an infinite run. So it's 0 over a number, so the slope of a horizontal line would be 0. And the last thing we're going to talk about in these lessons, we're given a couple things of a point and a slope, and I'm going to do this all on one graph so we can hopefully see what's going on. I'm going to do the first one in red. If I'm given a point 3, -4, and the slope is -3/5, that's enough information to graph this linear line. So I would go to 3, -4 on the graph, and I would go down 3, and then right 5, and I would plot my point, and I would draw my line. If you're using graph paper, yours will hopefully look a little bit more accurate than mine does. Let's do this next one in blue. If I'm going to graph this one at 2, 0, and then go down 3 over 5, that's too many, but over 5, and I connect those and draw those. What you'll notice is, and again, if you're using graph paper, it's going to be more accurate, these will never intersect. And those are called parallel lines. And those are parallel because, hopefully you noticed, that their slopes are the same. And finally, let's do this last one in green. If I plot the point -3, 5, and I go up 5 over 3, and then connect those, and I should extend those other ones as well. You'll notice that the green and the red line intersect at a 90-degree angle, and you'll hopefully recall that those are perpendicular. And they're perpendicular because these are opposite reciprocals. Notice one's negative, one's positive, and again, they are flipped, aka reciprocals. Alright, that's the end. Again, make sure you're actually reading the sections as we're going through this chapter, because there will be things that you may need a refresher in.